I will introduce our first speaker. This is going to be Dr. Franci Gabrosweck. He's a professor and scientist and physicist with the Slovenian Karst Research Institute. He received his PhD in computer modeling of karst aquifer evolution at the University of Bremen in 2000. He combines field observations and computer models to study active karst processes like flow, transport, and chemistry, and the evolution of karst. So I'm going to turn it over to him.
Okay, thank you for the introduction. Well, I'm sorry for not being able to see you all live because there's a lot of people I can see in this session which I really would be happy to meet. But unfortunately, the times are like they are, and I hope we meet us soon. So my presentation, actually, my poster today is on the environmental modeling in Scotland, and actually in environmental monitoring at this time in Scotian caves in Slovenia. I will share the screen. I hope you can see. This is a poster. Well, Scotian caves, I guess you more or less heard about them. It's a flagship of classical karst. It's part of dynamic karst. It's an allogenic cave fed by allogenic river Reka, which has a very variable recharge. It goes almost from nothing to over 300 cubic meters per second. This causes, of course, also very large water level fluctuations, which can reach more than 100 meters in several hours. The cave is known for its large underground canyon, and which is about 2 kilometers long. It reaches height of over 100 meters. It can get more than 50 meters wide. It ends with a chamber with 2.5 million cubic meters. So it's a magnificent cave and a magnificent site, and it's been a tourist site for over 200 years. The number of tourists had been increasing during last pre-COVID years. This year, it was cut down to, I guess Tomasz would know better, 25% or so. But during last years, the yearly number of visitors was increasing by 15% per year or so, reaching almost 200,000 in last year. And of course, there are concerns also about the cave environments, not only related to tourists, because even if you can imagine that the river which flows through the canyon can practically completely flood the active parts of the cave, including infrastructure, and well, not to mention that there are potential visitors in there, but I hope that this does not happen. Actually, this is quite well under control. So the environmental monitoring is being, of course, manifold. We do regularly monitor biota, microbiota, particularly microbiota related to light eutrophication or lampan flora, if you want. Here, I just would like to stress the kind of monitoring backbone that we are working on. Currently, we have 4 meteo stations following those main meteorological parameters like temperature, CO2, airflow, etc. And these stations are, in fact, continuously connected to the web. We have all data collected on a web server and on a data server, and these data are being immediately quality controlled, and are then, of course, we can harvest all these data with this tailor-suited software that we have developed, or our collaborators have developed. Actually, all the data of the last days can be seen publicly on the website. So we have graphs of the last days, including all these environmental data in the cave. That is at the moment mostly microclimatic data, but additionally, we also harvest data from the public service, from the public websites, like environmental agency offers access to the flow of the river, to the rain in the surrounding. And one of the things which we are additionally doing is that based on these external data like the rain gauges from the rivershed, we also developed a program code based on machine learning that we try to predict the floods in the next 6 hours or so. That would also this would also be a part of some kind of early warning system for the floods. So this is shortly what I have to say. So I don't want to provide you more data because it's really hard to do it in this short time. There are some links on my poster that you can follow with some recently published papers that would probably give you some more insight into what I've been shortly presenting. So thank you.
Awesome. Thank you so much. We've got about 4 minutes left for questions. If anybody has questions, Amy, I don't know if anyone sent any to you in the chat.
I didn't get any specifically. I think maybe we could open it up to.
Yeah. Are participants able to unmute themselves? Or, oh, okay, Chris Groves. Amy, if you can find Chris.
Yes.
He would like to be unmuted. He has a question.
Participants can unmute themselves at this point.
Okay, sounds like Chris, if you can unmute yourself, you can go ahead and ask your question.
Great, thank you. So, well, Franci, thank you very much. And I do wish you were here, but even more, I wish I was in Slovenia right now. So I hope things are well there. I have just kind of a side question. So this is one of the most fantastic caves in the world. And and Martin Knez told me some things about it one time. And I guess one incredible aspect is that the river there, the River Reka, actually comes out in the next country in Italy,
Yeah.
Springs. And the question I have for you, he mentioned in passing that one of the other fantastic things is that apparently at the Tamova Springs, where the river comes out in Italy, that Jason and the Argonauts stopped and got water there on their way to find the Golden Fleece. And I wonder what we know about that.
Well, this is, there's been probably, I mean, I know that practically since the antique times, the people, there were some writings or some that we know that already at that time they expected that this is the same water. I mean, it's also one of the first water tracing experiments in the world, in the history, which has been done here. And this water has always been kind of, a very important aspect of life. Actually, the whole exploration of the cave was due to the water supply of Trieste, which is on the other side of the Karst plateau. And I must say that I don't know really how they would supply Trieste, even if they would find or find the cave, or even if they would explore it further. But in fact, these, in a way, at the beginning, the practical course finding water for the town ended up in a passion for exploration, which drew them to explore that, and what you will also see in Tamas' presentation. But actually, I don't know much more about the Argonauts. I know that they supposed to stop at the Ljubljanica spring, which is on the other side of these classical karsts, which flows through to the Black Sea, and then they had to cross over the harsh land and continue in Adriatic. So.
Well, a fantastic thing too about the springs there is its position at Trieste at the top of the Adriatic Sea means that anyone coming from Greece, from Asia into Western Europe, that right around, right at the very northern tip of the Adriatic Sea was the most efficient the fastest way. And so, I thought at those springs, they must be, since it's right on the path between Europe and Asia, they must have been, among the most visited springs really anywhere in the world. So yeah, thank you so much.
Thank you.
Awesome, thank you. That takes us to our time, so I will go ahead and introduce our next speaker. Our next speaker is Isabella Serranolesso. She is a PhD student in the Department of Earth and Environmental Sciences at Aldo Moro University in Bari, Italy. The topic of her research is karst hydrogeology. All right.
Good morning, good afternoon, or evening to everyone. Our poster regards the fragility of karst groundwater in Apulia region, southern Italy, and some activities useful to protect the underground freshwater reserves. And in following slides, I will give you some information to better explain this matter. Apulia is the hill of the Italian boot, and it is an almost entirely karst region with limestone cropping out in three main zones: Gargano in north, Murge in the central part, and Salento Peninsula in the southernmost zone of the region, allowing widespread presence of karst landforms. The lack of superficial runoff here is a direct consequence of karst, of course, and the only freshwater reserves is under the ground. Okay. More than 2,000 caves are registered in a regional inventory, but among them, only 2 reach groundwater through passages large enough to allow cavers to directly arrive at the water table. Grotta Rotolo, here, opens in the Murge Plateau at the bottom of Canale di Pirropolie. It is totally developed in Cretaceous limestone and show very large spaces. It is the deepest cave in Apulia, reaching groundwater at a depth of about 260 meters below the topographic surface. And the other cave, Borabosco, that is here, is totally different from the previous because it develops in calcarenites and only the last 10 meters are in limestone bedrock. Here, the groundwater is found 60 meters below the ground. The importance of these 2 caves is the chance to direct monitor groundwater. Oops. I'm sorry. And to get more direct data about hydrogeology of Apulian karst. Unluckily, in Apulia, regional authorities did not pay attention to Apulian karst, and the result is that the groundwater quality is affected by natural and anthropic pollution, contributing to reduction of freshwater reserves. Seawater intrusion, here highlighted in yellow, as you can see, affects the almost entire coastlines, especially in Salento, where in the central sector, we can see a kind of link, underground link between the Adriatic and Ionian seas. This is related, in addition to the karst nature of Apulia and problems linked with global warming, to the high number of wells, here highlighted in blue, that exploit a huge amount of fresh water. Further, the groundwater quality is threatened by human industrial activities, and all these factors all these factors contribute to reduction of available freshwater volume. For this reason, protection of karst groundwater resources in Apulia is necessary and extremely important in such an environment. But recently, thanks to regional funds, we were able to perform a series of activities at the surface and inside caves. Thanks to Caver's help, we installed underground some sensors to monitor the cave microclimate and a multi-parameter probe below water table. We performed a biospeleological survey to assess the groundwater quality, diving exploration in Rotolo Cave, groundwater samples chemical analysis, and petrological characterization of rocks in which the cave developed. At the surface, we realized the karst geomorphological map of the area in which the caves open, studying the main karst features as endorheic basins or endolines that have an important role, hydraulic role in the aquifer research. We are also installed a rain gauge station close to caves and perform a geostructural characterization to compare the result at the surface with the main direction of caves. We are also searching for springs along the coastline to monitor the discharge and chemical and microbiological parameters of water at the output of karst system. So we are collecting data to add knowledge to karst Apulian hydrogeology with final aim to protect this highly fragile environment. Thank you for your kind attention.
Awesome. Thank you so much, Serena. Do we have any questions from the audience? We've got about 4 minutes left for some questions. Looks like there's one in the chat.
I'm not sure, Dar SB, I'm not sure what your first name is, but if you want to ask Serena your question.
Isabella, is there any observed information in caves?
You should be able to unmute yourself.
I'm reading a question from George Benny. And,
okay.
No, from Dyer SB. The structure of caves, the main direction of caves in Apulia are highly influenced by tectonics. Indeed, in the Grotta Rotolo area, we have found that the caves that opens at the bottom of the polye, that is elongated in east-west direction, has the same direction of the elongation of the polye, while the caves that opens out of this polye reflects the main direction, tectonical direction of the region, northwest, northeast, southwest, northeast, southwest, and southwest, northeast.
It looks like you also have a question from George Venny.
Yes. Are you considering any modeling of impact or rising sea level? Yes. I try to simulate the freshwater volume reduction in function of the rising sea level, in function of the Gibbon-Herzberg interface movement inland. And we found that until 2200, the total reduction of freshwater volume respect to the present is about 16% of the current freshwater resources. But we are trying to improve this model because it's not so accurate, in my opinion.
Awesome. Do we have any other questions? We got about a minute left. All right. Awesome. Great job. Thank you so much, Serena. Did I hear? Okay. Awesome. Then we will move on to our next speaker, Mario Parise. He is an associate professor at the Earth and Environmental Department at Aldo Moro University in Bari, Italy. He's a karst scientist and a caver who's interested in cave exploration and speleogenesis, sinkholes, and geohazards in karst.
Thank you very much for the introduction, Marissa. And I will start by sharing my screen. Okay. Thank you for this opportunity to present you this work, which regards the proposal of establishing a geopark in Alta Murgia, a part of Apulia. Serena just was talking about this region. In this presentation, I will be helped by this guy, locally known as Cicillo, which means Little Francis. He has become the symbol of this part of Apulia, as I will show later on, and will guide you together with me in the introduction to our poster. As said before, we are located in Apulia, the peninsula making the southeastern sector of Italy, a region almost entirely made of carbonate rocks and therefore highly interested by karst processes. In 2004, the national park Alta Murgia was here established, including 70,000 hectares in 13 municipalities. From a geological standpoint, this is part of the Apulian foreland, the sector which was not directly involved in the formation during the building up of the Apennine chain in Miocene time. The name Murgia comes from a pre-Indo-European language meaning rock due to its bare aspect, that is, exposure of the limestone. The main reason at the origin of our proposal to establish a geopark in Alta Murgia is given by a geological uniqueness, which I will briefly explain going back to paleogeography. The Apulia platform was one of the paleogeographic domains developed on the greater Adria plate during Mesozoic. The Adria plate was later involved in the convergence between Africa and Eurasia, and only a small crustal sector of it, which is shown in dark green in this slide, is still rooted on its original position with respect to the mantle. Nowadays, Murgia is the only part of this rooted sector which crops out, while other paleogeographic crustal parts of the original Adria are today deformed and exposed in the mountain chains surrounding the Adriatic Sea. In addition to this remarkable geological situation, we have a variety of features worth to be pointed out. Let's go back to Cicillo. It was discovered in 1993 by cavers within a small room of the Lamalunga cave. In the upper left corner photo, we are entering the cave through a 10-meter deep shaft. And Cicillo represents the most extraordinary remains of a complete Neanderthal man in the world. Entirely covered by calcite, it was dated by uranium thorium on the coralloid speleothems, providing a minimum age of about 150,000 years before present. Few kilometers apart, at the site of an abandoned quarry, thousands of dinosaur footprints have been discovered a few decades ago and are at present the object of detailed study. Among the other features in Alta Murgia, huge collapsed sinkholes such as the Pulo di Altamura in the photo in the center of the slide, hosting about 10 karst caves, including the main swallow hole at its bottom. Also, Murgetta Rossa, meaning Little Red Murgia, where several meters of bauxite deposits mark the paleokarst phases corresponding to the first stages of immersion of this sector of Apulia and the onset of karst processes. Other cultural and historic elements have also to be taken into account, such as the link between man and limestone rocks. These have been used since a long time to build dry stone walls, erected without the use of any mortar, but putting together the pieces of rocks found in the fields with the multifunction. delimiting the fields, sustaining the steepest slopes, keeping livestock inside the properties, and creating peculiar ecosystems where water is kept for longer times, thus allowing presence of typical flora and fauna. Again, about water, other structures were built close to the surface or underground to keep the water, as this cistern, or impressive underground aqueducts, as this one at Gravina, where the terminal bridge canal brings the water to the town, crossing the deeply incised Karst Valley. By the way, this bridge was recently one of the sets for the last James Bond movie, No Time to Die, coming up in the theaters in November. And eventually, still again about the use of limestone rocks to build remarkable structures such as Castel del Monte, an octagonal-shaped castle built in the 13th century by Frederick II and included since 1996 in the UNESCO World Heritage List as an example of medieval architecture. For all of this and many other reasons as well, linking geology, landscape, karst, history, and human presence, we are strongly convinced of the proposal to have Alta Murgia as a geopark and plan within a couple of years to present our proposal to UNESCO. That's all for now. Thank you very much for your attention.
Awesome. Thank you so much. That was really great. So we have about, and again, another 4 minutes for questions. Reminder to our audience that you can unmute yourself if you do have a question to ask, or you're welcome to post it in the chat.
There is a question in the chat. I don't know if it may be easier to read that. It's from one of our Chinese colleagues, and it's asking about the red soil cover. It says the red soil covering the rock is from the Cretaceous rock weathering, and what kind of rock?
Well, actually, the one that was shown in the picture at Murgetta Rossa was bauxite deposits coming from, as I said, the first phase of karst processes in the area. But of course, we have a lot of terra rossa, red earth, all over the region and also in Alta Murgia from different phases. And very often, many of our caves are totally or partly filled by these deposits.
Thank you.
You're welcome.
Say grazie.
Grazie, correct.
How do you rehabilitate the rock, the quarry, rock quarry?
The quarry?
How do you rehabilitate? You pick away the rock, you have a very big quarry, and it is very not so convenient for scenery, for tourism, or it's necessary to recover the quarry.
Ah, I see. You are talking about the recovery of the many quarry present in the area for geotourism, if I understood well. This is actually a problem because there are several quarries that were used in the past, and we also had some problems between quarrying activity and cave exploration, because in some cases the advancement of quarries destroyed some of the caves. Now it is growing a greater awareness about the importance of karst, and thanks to this we are trying to use some of the quarry also for teaching the importance of karst to scholars, young pupils, and also to explaining it to tourists. But much work is needed to be done in that direction for sure.
Awesome. And we have one other question from Tamas
Yes,
Travis?
I'm reading it.
Yeah.
Yes, geoparks are initiated by local communities. Of course, this proposal comes from my department at University Aldo Moro, together with a national park. And in the national park, there are included the municipalities. So we also have local communities involved. This is, of course, a long process. So we need to work a lot with them to raise the awareness of karst, of the natural resources, and to involve them as much as possible in this process of pushing together the importance of the geopark. As you have seen, the geopark will not only be focused on karst, but also on other geological elements and features. This means that we are working a lot to make people aware of the importance of a geological knowledge in the area where they live.
Awesome. Thank you so much, Maya. We're going to move on to our next speaker.
Thank you.
Our next speaker is Rosario Rogieri. He is the head of the Hybelian Center for Speleohydrological Research in Italy. He has his PhD in karst hydrogeology. I'm not sure I see him in the list. Oh, he was here earlier. We have Rosario.
Amy? Does Amy have his presentation perhaps? That I think he sent us a recording.
Okay, yeah. Amy, do you have his?
I'm sorry, I thought I saw his name earlier too.
Yeah, I did see him earlier, I'm pretty sure. But maybe he had to take care of something.
Hello everybody, I'm Fadil.
Amy, are you gonna play that or do you want me to?
Can you play it? I messaged you.
Oh, I'm sorry. Okay. So Marissa, would you like to go ahead and introduce the speaker?
Yeah, okay, I can do it again.
I'm sorry if you already heard that.
Yeah, I already did the introduction, but he's the head of the Hybelian Center for Speleohydrological Research in Italy, and he has his PhD in karst hydrogeology. So we'll hear from Rosario Rogieri.
I'm very happy. Hello everybody, I'm Ferdinando Di Donna. I'm very happy to be here to this Karst 2020 workshop on conservation of fragile karst resources for the poster talk session. Here we are presenting our initiative, Clean Up the Dark, that has been worked with Francesco Maurano, Vincenzo Martimucci, and Rosario Rogieri. Let's see what is this Clean Up the Dark and how it works. Clean Up the Dark is an initiative connected to the global Clean Up the World initiative that in Italy is led by the Legambiente NGO. The Legambiente is an organization that work in a wide sense in Italy, specifically on the environmental issue. And the Italian Speleological Society, SSA, it's the national organization that since 2005, already 15 years, operates on all the territory of Italy. We will see some of that are also in the poster, based on a volunteer support of hundreds of cavers in all the regions from Italy. Actually, sorry, I'm floating this image. The panorama that we have in Italy is we have a register of more than 40,000 caves where all the caves have been recorded, explored, and documented, mainly in carbonate rocks, limestone and dolomites, but there are numerous caves also in gypsum and basaltic. And also we have other natural caves in other kind of lithotypes. You can see here the poster that we have shared with you. And it's something quite common that the underground is used to hide waste. This is something that is a problem that we have seen not only in Italy, and we all know that the main damages are caused to the karst environment itself, the change of the karst surfaces, but also the change of deep water resources, and these are very, very big damages. So what we have done with the first year, we start with a massive decontamination action in sensitive sites. And as you can see, the conditions were not were very complicated, and many cavers start with rescue techniques to pick up the garbage in an organization or within other groups or within other supporters such as Legambiente. So also we start simultaneously a campaign to waste pick up also on the surface. So we were working with the yellow shirts people are from Legambiente that help us to clean outside also and try to clean all the site. Also was very important relationship with local authorities and press. As you can see, there were some newspapers starting to support our project, and seems something logical, but one of the complicated part was exactly the pickup of the surface. So we asked to the municipality many times to support the initiative, offering transport and a site where we can dispose of all the garbages. And it's very important that also not only karst and cave, but also archaeological sites and hypogea have been touched with this problem of garbage disposal. And you can see here some picture also from the province of Naples in Cuma. And parallel to the activity, what was very important also was a public action. So we think that the formula of this Clean Up the Dark is public action, awareness campaigns, depollution activities that give us karst and cave protection. So as you can see, part of the work was not only clean the caves, but also open the table to discussion, public discussion with the administration about the importance of caves and karst, and also how we can manage in a better way our land. And the publication of information and flyers and press campaign for local media has given us an outreach very interesting. We have an estimation of 2.5 million of general public and an outreach direct of 3,500 members of our organization. So we leave to each organization the open floor to design their own flyers, to use their own motif or idea, And normally the date that we have been using is in September, like the Clean Up the World initiative that is also in September. What we have take out so far, we have an estimation of the collection that is made by each group that works in cleaning the caves, and for the moment we have over 40,000 kilos of material that has picked out from caves. In sense also of work, the people that has collaborate, we have registered the hours, and there are more than 64,000 hours. And again, we have more activity in Puglia and Veneto, but also you can see other regions. There were a lot of cavers working during this past 15 years. Also, we have tried to assess the value of the work, and it's about over 2 million of USD dollars in value of voluntary work. And you can see that this has like a very high level of engagement at the first moments in time, and then you can see was a period which were less activity, and then now from 2016, and you will also understand why, we have been raising up the number of activities and hours of work in cleaning caves. But not only caves, as I mentioned to you, but also karstic areas. What we have done as Italian Speleological Society also is have a survey of the environmental hazard and of the activity. So we asked to the people to also make some records of the activity they've done, and build a database of the site that have been polluted, what kind of pollution was present, and the activity itself. Our data repository started in 2005, and we have an online update version, and we refer to environmental hazard.
Okay, unfortunately, I had not reviewed the whole video and didn't realize that he had sent us a 15-minute presentation rather than a 10-minute. So that is available online if you want to continue watching that, but we're already about 5 minutes behind in our session. And so we want to give everyone that is present their time. So I'll hand it back over to you, Marissa.
All right, thanks, Leanne. Our next presenter, I will go ahead and introduce, is Tamas Sarman. He is the Chief Ranger at Fragile Caves Regional Park World Heritage Site, which is situated in the classical karst area of Slovenia. He's a speleologist and national instructor of rangers and cave guides. Nature philosophy is his work and hobby. Tamas?
Thank you very much for the introduction, and I'm pleased to have the opportunity to be a part of the workshop. I would like to show you a very short film about the people living in the classical karst area, because I think we are a little bit too much spoiled if we are talking about the karst phenomena, about the caves. That means that mostly we are not aware of what we have and which is the heritage we have to be proud of. That's why we made a film which is showing about our coexistence in the mostly in the Scotian caves, which is well known since the prehistorical times, where the locals have played all the time the leading role in the research development and of course the conservation of the nature. If we look at the time of Bronze Age, they were the ones who run the internationally important pilgrimage center, and which is a significance that has been taken to the new days as the nomination for the World Heritage Site, for the Ramsar site, and also the Man and Biosphere Reserve. These are so set, very well-known trademarks which are saying which is the importance of the place. However, Franci already mentioned, we celebrated the 200th anniversary of the tourist development of the caves. And I can say that the caves are in our genes. So we are really karst men. The goal of the movie and the presentation is, of course, the importance of the cultural and natural heritage. And we want to encourage the positive attitude to this heritage for the local people, of course, and for the all tourists which are coming here, which are looking at our films and visiting our cave, to encourage our proud, let's say. Okay, more or less this is the thing I want to say. The film looks like this. But however, you can find it on YouTube, and I would like to ask Amy to have a short look at the history of these explorations and to our film. Thank you.
The Alps, glistening in the sunshine, do not contain all of the natural beauty. Not only on a snow-covered glacier, a fragile edge or a ledge can a daring man show his courage, his agility. The world above ground gets a worthy competitor in the beauty pageant in its dark sister, the underground. Whoever did, walking through her catacombs, glimpsed the wonderful shapes, the work of millennia, they must have felt the attraction of the dark spaces wherein the glow of light conjures wonderful, unimagined images. The ground sparkling as if covered by thousands of jewels. What opposites there are within these dark chambers, from the barely audible sound of falling water drops that ceaselessly build cave formations within this silent world, to the thundering roar of water caves, where crashing flows of water shake the ground.
Moramo kaj zaslužiti. Si rešil štali? Ma vse je poštimano, je porabljeno, cenu in vse.
Si nam gojo krave?
Sem, pomozli smo vse.
Ja, in volcem si dal volcem.
Tudi?
Ja, prav.
Ne vem, skozi to luko. Bomo stala z vama in kje bom?
A se zaslužimo, se je dober solt. Evo ja, naprej.
Grejo?
Bog dal, dober dan. Alo, misliš, Franko? Vsi štriki so zle.
Ja. Ему добър не наш, jer vse poskrbuje, delo vse pošršati.
Vemo, ki je ura cajt. Dobro, vežmo.
Srečno, srečno, srečno. Aktite, da ne padaš, veš, da se ti nekaj spodrsne v kakšnem kraju, da tukaj je mokro, nasvidenje.
Not without difficulty are we advancing toward the entrance of the cave, and terrified by the distant roaring of the underground waterfall, we admit to ourselves that exploring the caves in Skocjan is a respectable undertaking. Boats. Double troughs that look like a couple of planks nailed together don't really evoke trust. Amidst the great preparations for the crossing of the drop of the sixth waterfall, rain occurred on the 6th of March 1851 and swelled the Reka River. Everything, 3 boats, planks and machinery, was washed away by the swollen river, and Schmidl's research was suddenly over for a full 33 years. Mining expert Hanke, fearless, full of ceaseless strength, the first to advance, the last to return, was the person at the head who led us toward the common successes. Iron bolts that should serve for attaching the boat are being fixed into the rocks. One of the bolts has a rope ladder hanging from it, and Hanke climbs down to explore the depth. It is with unease that we watch him disappear.
We're gonna pause it there, and if you guys, that's just a little clip, a little taste of Tamas's video. If you guys have any questions for him, he'd be happy to take those now, I'm sure.
Of course. I already wrote down, that's the YouTube address where you can find the video. However, Skocjan Caves and the Cave and the Journey of its Explorers is the title.
I have a question.
And you have to look at the full-time 56 minutes version, because there you can find an old explorers and the new days explorers, so they are combined. The old and the new ones, how it was done in the past, how it's done today. It's a good, let's say, comparison.
Chris, do you have a question?
Yeah, I have a question. Can you hear me, Tamas? In the cave, in the main canyon, there's places from, you know, old times where very high on the walls, you know, maybe 30, 40 meters up or more. There's places where there's steps, or, you know, places where it looks like people were trying to climb on those walls, terrifyingly high. Was that to try to find side passages, or what motivated people to climb so high on those walls?
You must know that our cave is a very huge one.
Yeah.
The underground spaces are immense. So with that candle or a torch, they couldn't see a lot. So they tried to find something else to climb and to find a new space, a new cave, a new sail. And that's why they climb all around. And the second reason is that they knew that this river disappearing underground has a torrent character. So the river can rise very high in a few hours, let's say. Franci already told you, the floods are very huge and immense. So a lot of paths are leading right towards the ceiling, and they are called escaping paths to escape and not to be flooded. Right. So a lot of times they were used, they escape on the right on the ceiling. They wait there for a day, 2 or 3.
Oh no, that's terrible.
They were safe, they were alive, and then they came back home still alive.
Yeah, thank you.
You're welcome. And of course, yeah, I have to mention all these pets were handmade. So you will see in the film, we try to reproduct how they were made. So this was an immense work of years and years underground with of course, a work of local people. A lot of
much braver than me. It frightened me.
A lot of, let's say, rich people from Trieste or Vienna paid local people to do a path to unknown sail, and after that path was made mostly during the winter time when the locals have time, because otherwise they were farmers. So they made the path. They wrote down the letter, "Dear sir, your path is done. Please came and discover your cave or your sail." And that man then come. They however discovered the cave, and then they write down nice books when they explained how this exploration has been done and so on and so on. But however, all this was officially done before by the locals. It's like in Himalaya, Sherpas who are carrying everything, but the other people are saying that they came till there.
Awesome. Thank you so much, Tamas. It looks like an awesome film, and I'm definitely going to go back and watch it. I'm going to keep moving along here. We're a little behind, but I'm going to introduce our next speaker. Our next speaker is Dr. Phil Van Baynen. He's an associate professor at the University of South Florida in Tampa, Florida. His karst-related research includes paleo-environmental change, human disturbance of karst environments, and their sustainable use.
Hi everybody, thank you very much. It's a hard presentation to follow. In Florida, we're very, very flat and not much to see as far as the karst go, except for lots and lots of sinkholes. So hopefully you guys can see my presentation. Can you see the full one, or you just see part of the, how is that? All right.
We're seeing the presenter mode, so yeah, if you swap, there you go.
All right, excellent. So today I'm going to be talking about investigating the extractive value of Florida's groundwater. I have Sean Landry, who is from the University of South Florida Water Institute. He is also a co-author on this. The main poster you can see on the Karst 2020 website, so I'm not going to show that. Just a few slides that'll look at certain aspects of the poster. So as way of introduction, this is a first attempt to provide a monetary estimate of the contribution to groundwater in Florida's economy. Now, what we use is extractive value. You can see what extractive value is here in the left-hand side of this diagram. It's mostly due to the direct use of Florida's groundwater. You can see municipalities, i.e. cities, agriculture, industrial, mining, amongst others, which we will be looking at a little later on. As far as Florida's groundwater goes, you can see the top picture there. There are 5 different aquifers. The sand gravel is to the top left-hand side. Then we have the superficial, the intermediate, and the Floridan aquifer. And then finally, we have the Biscayne, which is to the south around the city of Miami. The most important of the aquifers is the Floridan. You can see that it covers the entire state, but also Mississippi, Alabama, Georgia, and South Carolina. We'll just be concentrating on Florida. So as far as the extractions of groundwater, freshwater that's used in the state, you can see that agriculture and the cities use by far the most, almost 2 billion gallons per day for the cities, and around 1 billion gallons a day for irrigation of the crops. Below, you can see a summary of the different industries or sectors that use groundwater in Florida. The 3 big ones are agriculture, the golf courses. We have hundreds of golf courses in Florida, and also tourism. What I want to concentrate on will be the agriculture and the tourism, but the thing you can see here is that the value of Florida's groundwater, we estimate it to be almost $74 billion. To put that into some perspective though, the GDP of Florida is around $1 trillion. So starting with agriculture, this is quite a difficult one to work with. There are many different estimates of what each of these different sectors contribute or their values. We decided to use the University of Florida Institute of Food and Agricultural Sciences Extension. The big one is what is grown indoors, horticulture, but also citrus, of course, Florida, lots of oranges, but also vegetables, melons, tomatoes, strawberries are part of the vegetable category. But we're looking at something like $33 billion contributed to the economy by agriculture. Agriculture is a little bit difficult because it uses surface water and rainwater. However, many of the crops are grown during the dry season, which is quite pronounced in Florida, and therefore groundwater is certainly very important. In that area where we live in central West Florida, about 97% of the water for agriculture actually comes from the groundwater. The second case study is tourism. And tourism in Florida is one of the biggest industries. You've got Disney World, SeaWorld, Universal Studios, so those are very large. The ones that we wanted to concentrate on here were the theme parks that rely predominantly on groundwater. You can see the table here. Most of these are in Orlando, and the water in this region for these theme parks actually comes from the Reedy Creek Improvement District, which can extract something like 14 million gallons per day from the Floridan aquifer. The contributions of only these water-related theme parks is around $2.3 billion. However, if we want to concentrate purely on karst groundwater, i.e. tourism that's related on springs, there you can see that around 4.4 million people visit these state parks, and each of these state parks have at least one spring, and the money that's contributed by either the gate sales, i.e. direct income, or indirect from hotels and restaurants that people visit is over $380 million. Some of the limitations of this, creating these estimates, one is the water management districts. There are 5 of these which control the groundwater in Florida. They don't provide detailed lists of different enterprises, so it's difficult to calculate accurately how much comes from some of these sectors. And then we have these very large multinational corporations that have subsidiaries in Florida. Nestle, for example, uses groundwater for its bottling water industry, but that doesn't report earnings or water use at the finer scale that is Florida. Then we have direct, indirect income. It's not always possible to find the data for both direct or indirect income derived from these different industries. And certain industries, we mentioned golf, the golf sector, that does tend to inflate its income to the state. And the reason for that probably is if they want to open a new golf course, you know, if they can show the state just how much money they're bringing in, then the people in the Floridan government probably are more likely to say yes to those requests. Then we have contributions of groundwater to particular industries. Besides the bottled water industry, a lot of these industries use surface water, groundwater, and reclaimed water. So sometimes it's not possible to get exact contribution of groundwater to the income of each of these different industries.
You have about 3 minutes.
Yep. Finally, the challenges to Florida's groundwater. Over withdrawals is a problem in the state, which of course is common in many karst areas around the world. In the past, this is probably due to the lack of knowledge, but the main issue today is probably the low cost of water. Agricultural users only have to pay permits to use the water, which is only a couple $100, and don't actually have to pay for the water itself. Groundwater pollution, agriculture, urban areas, golf courses use quite a lot of fertilizer, but also pesticides, and these lead to the elevated values of nitrates and phosphates in the groundwater, but also pesticides and herbicides. Septic tanks are used in many areas in Florida. We have over 2 million septic tanks. And of course, this is for the disposal of human waste. So there's pharmaceuticals, personal care products, which are released into the groundwater, and these can be quite nasty contaminants. Wetlands in Florida are very important for the recharge of these aquifers, but something like 500,000 hectares has been drained. Human population, we have over 20 million people living above the karst environment in Florida. This is going to increase, so therefore water consumption is thought to maybe increase in the next 20, 30 years by up to 40%. We also have an aging population. The elderly use more drugs, therefore more of these nasty chemicals are going to be released into the groundwater. Finally, climate change. We all know that temperatures are going to rise. This will lead to more evaporation of the surface waters. Therefore, there's going to be an increase in the use of groundwater for irrigation. Sea level rise, especially in Florida being so flat with such an extent of coastline, there is going to be problems of saltwater intrusion because of this coastal flooding. Florida has a highly karstified limestone bedrock, and that really allows the intrusion of the saltwater into our groundwater. And that's it for my presentation.
All right, we've got time for maybe one question if we have somebody's got a question. Looks like there's one from Chris Groves. Chris, would you like to ask your question?
Yeah, it looks like I'm unmuted. Yeah, Phil, excellent, and thank you very much for that. I guess what my question is, you mentioned the impacts to the water quality, you know, from golf courses and agriculture and urbanization. And I just wonder if, in the same way you quantify the value of the water resources, if there's a way to put, you know, to quantify the values of the costs, you know, from those contaminants, you know, in a way to, yeah, I don't know if that sort of helps the calculation of trying to figure out ways to, you know, to ameliorate those impacts.
Well, that would definitely be something that we could try in the future. Part of that could also come into the cost to ecosystems. And the very first diagram that I showed does have a section on the economic cost of ecosystems. They contribute a lot to the purifying the groundwater, but also they get contaminated. So that's one way you could do how you can reduce the economic benefit of ecosystems from the pollution. That wouldn't necessarily be extractive, but it definitely could be something that could be incorporated into trying to quantify the economic value, definitely.
Awesome, thank you so much. I think there is at least one other question in the chat for you, Philip. We gotta move on to our next speaker, but if you want to answer that.
All right, thank you very much.
Great. All right, so I'm going to introduce our next speaker here is Dr. Nahid Ghani. She's an associate professor of geology at Western Kentucky University. Dr. Ghani distinguished herself in landscape evolution, geomorphology, and tectonics research, and publishes papers in high-impact peer-reviewed journals, and secures various internal and external grants to support her research. So I will turn it over to Dr. Ghani. You're muted. I think you gotta unmute yourself. There you go.
Can you hear me?
Yes.
Good morning, everyone, and thank you for the nice introduction. I'm very glad to be here in this conference today. So I'm going to share my screen quickly. Can you able to see my screen?
Yes.
Okay. So this is the poster that we are presenting. We are looking at the geologic control of the Western Pennyroyal Karst region in Kentucky. Particularly, we are looking at the tectonic geomorphology in this area. So you can see the Pennyroyal region within the western part of Kentucky, right, in this location. And if you look at the broader geology around this area of Kentucky, you can see the different structural element in this area. So mostly what I'm going to talk about how the tectonic geomorphology in this area is affecting, or we basically don't know yet, it's an ongoing project, but how it is affecting the surface modern river systems in this area, and how it is linked with other geologic features. So if you look at a close-up view of this area, you can, I can zoom in a little more here in Kentucky. So you can see that this is the location within the Pennyroyal Karst region right here. And this area is very dominated by different types of fault systems within a very ancient continental rift, which is called the Rough Creek Graben. That is right here. So this is one border of the graben, and this is the southern border of the graben systems. And within the graben systems, there are some synclines, anticlinal features. There are other fault systems. This graben is tectonically connected with the here with the Mississippi embayment, where the real foot rift system is here. And that is part of the location where the New Madrid seismic zone is. But today it is an active seismic zone, and the faults in there are actively moving. So if there are large earthquake happens in here, one of the largest ones that happened in 1812 and 11, if there is a large earthquake happens here, this seismic wave can propagate longer distance. So we obviously this Pennyroyal region or the western part of Kentucky very will affect. So if you look at the geology, it's a very generalized geology of the same location. So this is the area where the Rough Creek Grabens are. These are the large scale border fault systems. And this area are dominated by mostly Mississippian and Pennsylvanian rock systems, and majority of those are carbonate rocks. But we are mostly looking at what are the relations of this fault system with modern river systems. If we can tell anything, like today we know this is not tectonically very active. There are low seismic activities. The magnitudes are not more than 4 to 5, even lower magnitudes. So sometimes we cannot even realize there is an earthquake happening, but it's seismically inactive. However, the region in the New Madrid seismic zone around here, and also the Wabash Valley seismic zone north of us, they are very active seismically. So the goal is to know how these river systems within this Pennyroyal Karst region is basically affected by any kind of geologic activity today. So I'm going to move a little bit. So for this, we used different types of remote sensing data and field studies. So we use, here we use the ASTER DEM, and also use the SRTM DEM to actually extract any other structures that might be available in this area. So we basically use different techniques, like different types of filtering and radar shadow illumination effect. We use hill shading using different angles. So we found, using different types of measurement, we actually found lots of smaller scale lineaments. Many of those are normal faults. I guess majority of those are normal faults in this area within the Rough Creek Graben. So we field checked some of those faults. You can see here some examples of normal faults right there within the lithology or rock types within the rough creek graben. And then we created this map. Let me zoom out a little more. Okay, so this is the structural map that we created. So the red colors are all the structures that we have mapped from using the remote sensing data and different techniques. And then you can also see some of these maps are field checked, because not all of them, you can see many of these that we have extracted. And we have actually, these are within the 90% confidence interval. All these structures are drawn here. And we field checked many of those structures here. So mostly the trend that we have found within these structures are northwest, northeast, south, west trending, and some of these are east-west trending. You can see the trend rose diagrams of these trends. Then we actually looked at the seismic activity in this region and overlays the locations of the sinkholes and karst features. And we found that not the majority, but many of these structures are lined up with the sinkholes and some of the cave systems here within this area. So then next, we actually looked at the geomorphology, particularly the river systems. So it's to understand quantitatively how the rivers are responding to any of these structures that exist in this location. So we use the, we actually use the power law equation in the medium of ArcGIS and MATLAB, and also using the river tools stream profiler tool to actually quantitatively extract the river profiles.
We have about 3 minutes left.
Okay, river longitudinal profiles. And then these actually allow us to extract all these rivers. If you look at here, that how these profiles look like. So many of these profiles have nick points in them. And these are large scale nick points that we have verified that they are not controlled by any of those lithologic structures, the carbonate region, or the structures that we extracted. So these nick points, we are assuming that they are tectonic nick points. So they are somehow is controlling by the, or adjusting with the geology in this location. So we basically mapped out all these nick points and their steepness gradient values in here. So you can see the red ones are higher steepness areas in this area. So this is the one of the Green River drainage network in that study area. But you can see there are variabilities. So this higher KSN or the steepness index actually indicate that they are responding. They're not actually equilibrium rivers today, but they are responding to these surface geologic conditions, and which is very important to understand this karst region and the how it is controlling the surface water systems and groundwater systems. So we actually put together all of these elements with the location of different sinkhole data here. You can see, and found out some of the controls of these rivers are following, but most of the time we need to have, to understanding the nick points, we need to actually field checked what are these nick points and how, are they man-made, or are the most of these are actually the tectonic nick points. So this is an ongoing research. We recently got USGS grant for this work to look at very in-depth in the northern part of this location to look at the tectonic geomorphology, structures and stratigraphy, and how those are linked with the karst and cave systems in this area. So that's, I think, the basic idea of what we are doing in this work. There are 6 to 7 students, undergraduate and graduate students are also working in this project and different aspects of the project. I'll be happy to take any questions, and thanks for listening.
Awesome, thank you so much. There is a question in the chat. We are behind, so I'll have to move on to our next speaker, but if you want to take a look at the question in the chat and answer that, that would be great.
So I will stop sharing.
Okay.
Okay, thanks.
Our next speaker is going to be Jessica Williams. She's an undergraduate researcher under Dr. Chris Groves and has worked at the Crawford Hydrology Lab last year. She's double majoring in a self-designated major around critical zone science and Chinese with a double minor in chemistry and math. So Jessica?
Hi, I'm having some issues with my computer right now. Can you all hear me?
Yeah, we can hear you.
Awesome. I don't know if I'll be able to turn on my video. My Zoom meeting just disappeared off of my window, but I'm glad you all can hear me. Last year I was a part of 4 dye traces to delineate the boundaries of the Great Onyx Watershed at Mammoth Cave National Park. Great Onyx is a very pristine cave system. It's in a remote area of the park and has not been impacted by humans for nearly 50 years. You have to get a permit to be able to enter it and other things like that. So it makes a very good control for researching karst environments, specifically for landscape and atmospheric carbon dioxide interactions. In addition, the cave is also really accessible, so that also makes it a very good control. So the research that I did was, like I said, just figuring out the boundaries of the watershed there. So to begin with, we identified the locations on the surface and in the cave that could potentially be connected to the watershed. We also monitored known springs at the Green River during the dye traces as well. We performed 4 different dye traces. We did one at Three Sisters Hollow. We used fluorescein there, and that was outside of the cave. We also performed one at Great Onyx Hollow with Eocene, and that was also outside of the cave. Then we poured rhodamine WT at Lucy Cova Falls inside of the cave, and then SRB at the base of Biz Falls in the cave as well. And so to conduct these dye traces, we used the methodology from Crawford Hydrology Lab. And so that was very fun to be part of. I actually worked at the lab last year in the fall and the spring. And so it was really, really cool to do. So from the surface trace, from Three Sisters Hollow, we connected it to the Lucy Cova River in the cave, and the Lucy Cova River eventually was connected to the Great Onyx Spring outside of the cave. And so we established this as one single river. We also discovered that the main sink point of Three Sisters Hollow is right on the boundary of 2 different groundwater basins. And so the flow went both into the Great Onyx watershed and also into Pike Springs. We also figured out that at Great Onyx Spring, the main point where water flows out of, we actually figured out was an overflow route that only fills up during intense storms and water surges. And the lower flow that comes out of the spring runs into the Green River nearby. The Biz Falls stream was determined to be a tributary to the Lucy Cova River. And so we were able to connect the Biz Falls to Lucy Cova Falls because Biz Falls joins the Lucy Cova River upstream from Lucy Cova Falls. So yeah, it was very exciting in determining more about the boundaries in the watershed. This will help us with future research in that I will be working on, for my honors thesis project, I'll be working on analyzing atmospheric and landscape carbon dioxide interactions at the Great Onyx Cave. And so by understanding the watershed, we can we can understand how much water and how much carbon dioxide is going into one system and coming out. yeah, and so the research I'll be doing in the future will aid in our understanding of how karst and cave environments will be affected and have an effect on climate change. Does anyone have any questions?
Jessica, I might make a comment. Great job. I would just kind of like to tie this to what Will was talking about yesterday that some of you saw, that as Will had mentioned, this is a site, and in fact, as you mentioned, Jessica, to kind of look at carbon dynamics, but a very critical thing, for doing that kind of work is to delineate, the extent of the recharge area, of the area collecting rainfall, that's going into the flow system. And so this work, ties directly to that. The first thing is to understand the plumbing, I guess. And so the two aspects here, one is to continue to, this is a series of traces to continue to delineate the catchment. There's other previous dye tracing that's been done that we didn't have on that map, but also the internal plumbing. And so, for instance, you mentioned that Three Sisters Hollow, on the surface goes to Lucikova River in the cave. We now know, in fact, since subsequently that actually goes to Blindfish River in Mammoth Cave and into Great Onyx Spring. And so that's a kind of a flow through that gives access to different kind of sampling points. And that's another thing that Will, mentioned was that, that compared to, sort of shale aquifers, and that sort of things that, in karst areas, this really emphasizes how we can go in and, have sampling points, within the aquifer. So yes, so nice work, Jessica. Thank you.
Thank you. Awesome. We have a couple of minutes for questions. If anybody's got any questions. All right. Well, if you do have anything that comes up, just feel free to put it in the chat. We'll keep things moving along because we're a little bit behind. So I'm going to go ahead and introduce our last speaker. Our last speaker is Elena Gessert. She works in the field of karst research, karst geomorphology, and speleology at the University of Košice in Slovakia. Almost all of her scientific projects are located in the Slovak karst region, but she's been in scientific cooperation with Slovan University since 2017. She also serves as the Secretary General of the European Speleological Federation. We cannot hear you, Elena. No.
And now?
Yes, we can hear you now.
Okay, I will put it away. Okay, thank you very much. So, my poster is here. So thank you very much, dear all. I would like to present you our results of an international research project dealing with the karst national parks of Slovakia, Hungary, Serbia, Romania, Croatia, and Greece. And my colleague Tamas was presenting yesterday some results on the plenary session about the Tara National Park in Serbia. So I will go ahead a little bit with the Slovakia National Park. National Park of Slovak Karst, or Slovenský krast in our language, is the study area which is more than 600 kilometers square big, and it is very typical karst plateaus region with developed all karst forms and phenomenon. And we have more than 1,300 caves in the area. 4 of these are show caves. We have all types of the surface karst forms like dolines, skarn, polyas, and so on. And like you see, because of this, the area became a protected area 50 years ago, almost 50 years ago, in 1973. Later, in 1977, it became a part of the UNESCO Maiden Biosphere program, like a biosphere reserve. In 1995, all caves of the Slovak Karst and Untitled Karst in Hungary became a part of the UNESCO World Heritage Site and list. And in 2001, Domica cave, which is the transboundary cave going from Slovakia to Hungary in the length around 30 kilometers, is on the list of the wetlands of international importance of the Ramsar Convention. And from 2002, the newest title is a national park. Normally, we are dealing more with the geomorphology of the Slovak Karst area and the speleology, but in the part of the project is like behavioral research of the people which are living there, which are coming there like a tourist, and which are working there like experts or national park employees. So we decided to make questionnaires which are the same from the whole project, national parks, which I mentioned. And we were asking 150 local peoples, 330 tourists, only 3 national park employees and 7 external experts. National employees are only 3 because the whole national park of Slovak Karst has only 11 employees, and 4 of them are rangers, and the rest of these people are working like zoologists, botanists, landscape architects, secretary and director. So it's pretty low number of the employees of the national park comparing to another national parks with a karst character, like for example in Hungary or in Serbia. External experts are people working there in the field of the research, doesn't matter if in biology, geology, geomorphology or geography. So few information about our results. You can see here 2 maps, the localities or residents of the tourists which are coming. The national park is here in the east part of the Slovakia, only 40 kilometers from the second largest city of Košice. And this is the capital Bratislava, which is around 300 kilometers far away from the national park. And these are the localities of people living in the national park which were asked, we were collecting data in 2019. When you are having a look of this map, you see only few of the settlements are directly in the protected area of the national park. It's because only these 2 villages are directly in the national park, and because of the structure of the plateaus, which are without road connection, except this one where these two villages are. And the structure between the plateaus are very deep gorges and canyons with altitude difference about 300 or 400 meters above the sea level from the bottom of the gorge to the plateau surface. So to our results. Only a few points or few questions I chose for this poster, which I think they are interesting for us or for you to hear about it. We were asking if the people will move out from the region if there is a possibility. And more than 1/3 of the people asked yes. And many of them were talking not about bigger cities in Slovakia, but were talking about abroad regions, mainly about the Western Europe. but more than 60% will stay for sure. It is because of the bad living condition in the national park. What is connected first, what I was talking about, the character of the area, and second is about the bad transport possibilities, bad connection to the bigger cities, bus and train connections. There is only one train line going from Košice to Bratislava, which is not very the train is going only two times a day, for example. The second question was restrictions. That's the question of the national park restrictions. For example, there's forbidden the movement in the forest except marked roads, restricted to collect plants, mushrooms, fruits, wood, and so on, forbidden free camping. And for many people which are connecting to the nature and living there, it's a huge problem. Because
we've got about 3 minutes.
They are feeling somehow forgotten in the area. Then poor soils, lack of the water and drinking water, and the raw materials. Many of the people were talking about now too many tourists in the Slovak Karst, but I need to tell that this area is one of the less visited areas of the Slovakia when we are going to compare it with other national parks or biosphere reserves of the Slovakia. But on the other hand, they would like to have more tourism because they know that with more tourism is coming more development, more money, and improvement of the area. That's the result of the local people. About the tourism, we were asking foreign and Slovak tourism. The answers were different. First, many or the most of the Slovak tourism are coming only for 1 day to the area. When we are talking about the foreign tourism, they are coming for two till 4 days or more in general. But many of them are coming by the car because of these bad transport possibilities, which I was talking about with the family or friends. Foreign tourism is more with a travel agency. Another question was how they were deciding, why they were deciding to come there. Some of them are searching for relaxation and they wanted to come with a family or they are traveling through Slovakia. But what is interesting for us is this part. The most of the tourism, Slovak tourists are coming because of the personal information for friends or family. The second place was internet, and the third, schools are doing very good job because of the information from the school teachers, or they remember some information from schools. If you see here, there is no information from tourism information center or something because there's existing no tourism information center. This work is doing by mining museum in the city of Rožňa, which is in the center of the national park area, and some action groups which are connected to some villages and active people who would like to bring more tourists to the area. Last question only is about the title of the national park or UNESCO. What is more important for people living there? For local people, is more important national park title because many of them don't know that they are part of the UNESCO protected area, even they are living there. For tourism is for sure the Slovak or foreign tourists is more important to have a UNESCO title like the national park. What about national park tasks? only very short, you see the most number or mark points which they could to give to the questions of the national park was 5. So many of them are very near, but local tourists and also experts don't think that the main task of the national park is scientific research. Even the national park employees think that is. The difference is again about tourism. The people think that it's important that the national park is doing also this development of the tourism of the area, but a national park doesn't think this. And last point is values, what the Slovak tourists think and what locals. People are coming mainly because of the caves to the area. 88% are coming because of the Domica cave or another show caves of the area. But local people think that the biggest value of the national park is forest. It's more than 74%. And it is almost 80% of the national park are forested. So to the conclusions, everything what I taught, I think when we want to develop this area more, we need to have more tourists there, and there should be a significant and clear task of the national park in this point of view. We were talking to many people, to these questionnaires, to employers and so on. National park don't want to bring more tourists to the area. They think that it's enough now, and the main task is to preserve the area. From my point of view, I would say that the area, the national park, fell asleep a little bit in the time. So the situation which was there 30 years ago is the same now. So we need to give and to have more action in the area. Thank you very much.
Great, thanks, Elena. All right, well, that brings us to the end of our session. We are very much over time. If you do have some questions for Elena, we can maybe stick around for a little longer, but at this point, that concludes our session. We will continue the conference in about 15 minutes or so. We'll be at 10 a.m. will be the workshop sessions. I think Leanne maybe has a couple of things to say to us.
Well, I was just going to see if Elena wanted to address the one question that went through chat. It's from our colleagues, Helena, and I'm sorry I might pronounce your name incorrectly, Kalik. She was asking, how did you get? Sorry, I keep getting so many chats. How did you manage to collect so many tourist questionnaires? In Serbia, the tourists were lazy in filling the forms on the spot, so we decided to collect through Google Forms on the website. So if you want to make a couple comments on the actual survey process.
We were very happy with this number of the questionnaires. I had students there from a mapping course of the human geography, and they were in the very good time on many places in the Slovak karst area. So because of this, we were very, very lucky with the number of the questionnaires. I know it's problem. Many of them don't want to answer the questions because of information protection, and if the question was too long, they don't want to read it, for example. But in fact, we have this more than 300 questionnaires, and it's very good.